evaluate the following integral by using sums and limits. We have the integral from 0 to 4 of x squared dx. Now, we know that we can write that in terms of a limit of a sum. So this is going to be the limit as n approaches infinity of the sum as I goes from 1 to n of f of x sub I delta x. And we're going to need to figure out what f of x sub I and delta x are. Now we know that delta x is b minus a over n. In this case, if we subtract b minus a, that's 4 minus 0, which is 4. So that's 4 over n. And we know that x sub I is a plus I delta x. In this case, a, our lower limit, is 0. And so that's just going to be 4i over n. Because delta x is 4 over n, and we're multiplying it by I. So that's going to be our x sub I. And we know that our function is the squaring function. So f of x sub I is going to be 4i over n quantity squared. So let's write that out. This is the limit as n approaches infinity of the sum as I ranges from 1 to n of our function evaluated at x sub I. So it's going to be 4i over n squared times delta x. It's going to be 4 over n. And then we can simplify everything in there and multiply them together. So 4 squared is 16 times 4 is going to be 64. And then that I squared is I squared. And in the denominator, we're going to have n cubed because we had an n squared from here and then another n there. And we know that if we're looking at this sum, the variable between the terms in that sum is I. I is the thing that's changing. And so 64 over n cubed, those are actually constants with respect to this sum, because this variable of the sum is I. So we can pull those outside of the sum and write this as the limit as n approaches infinity of 64 over n cubed times the sum as I ranges from 1 to n of I squared. Now, we had some formulas for sums like this that we saw in one of the videos. And if we are taking this particular sum, we know that it is equal to n times n plus 1 times 2n plus 1 all over 6. So if we make that substitution, if we make that replacement, then we've got 64 over n cubed times n plus 1 times 2n plus 1 all over 6. What I'm going to do is I'm going to rearrange things so that we can look at each of these bits kind of in a nice separate way. I'm going to put the constants out front. And we can actually reduce those. 64 over 6, that reduces by 2. So that's going to be 32 over 3. And then we have times. I'm going to split this up into 3 things. I'm going to put the n over one of the n's, the n plus 1 over another n, and the 2n plus 1 over another n. And then we're going to be able to simplify each of these. It's going to help us evaluate that limit. So we still have the limit as n approaches infinity. And I hope when you're writing these out, you are including the limit every single time, and you're including the sum until we evaluate what that sum is, and not skipping those things. That's a bad habit to get into. Anyways, I digress. We've got 32 over 3 times. N over n is just 1. And then if we take n plus 1 over n and separate it out, n over n is 1. And then we've got plus 1 over n. And then over here, if we separate it out as well, we're going to have 2 plus 1 over n. And we know that in each of these, as n goes to infinity, 1 over n goes to 0. And so when we're evaluating this limit, we can just multiply those, putting in zeros for 1 over n's. So we've got 32 over 3 times 1 times 1 times 2. And that's going to give us 64 over 3, which is the value of that integral.